Hi, Captain Peter Cutsey in another of my online videos. Today we're going to cover HUD, heads-up display. Here's a picture on screen of the primary mode. Before we get into the different modes, I'd like to point out some of the important angles that pilots should be aware of when you're using the HUD and you're trying to understand this little display up here called the angle of attack. Let's look at the critical angles, three critical angles. We have a pitch angle, flight path angle, and angle of attack. This diagram describes them beautifully. The first one, easy to understand, is the pitch angle. That's what you pitch to when you rotate after takeoff. Let's say you rotate up to 15 degrees on your primary flight display. Well, that angle is the angle the longitudinal axis, this axis here, is making with the horizon. We learned that when we first started to fly. The second angle is called the flight path angle. Well, what is the flight path angle? Well, that's the actual angle that the aircraft itself, its flight path, is making with the horizon. A good way to think about that on takeoff is as follows. Let's say you're at 79,015 tons, kilos, max takeoff weight, and the temperature is plus 40, and you're at a high altitude airport. You'll rotate to 15 degrees once on takeoff, but your actual flight path will be considerably less because you're hot and heavy. You'll be pitched at 15 degrees, but the angle that the aircraft's path is actually making with the horizon will be quite a bit less. Could be 8 degrees, whatever. Conversely, if you were lightweight, and taking off at a sea level airport, and let's say the temperature was minus 30, you're still going to pitch to 15 degrees above the horizon on rotation. That's your angle of pitch. The longitudinal axis makes that with the horizon. But your flight path angle is going to be closer to 15 degrees because you're light. It'll be less than 15, but not as small as it would be if you were hot and heavy. That's one way to understand it. So the angle between the flight path angle and the pitch angle is called the angle of attack. So the angle of attack is the difference between those two angles. Well, there it is here. Let's have a look at maybe in a very simple way of what we're talking about on approach. On approach, this is your airplane, this is your tail, and this is a 3-degree glide path. It's fixed. You're on an ILS. So your flight path angle is really -3. -3 degrees. There it is here. Your pitch angle, on the other hand, is, let's say for all intents purposes, you're at flaps 30 at 60 tons, would be close to 2 degrees up at flaps 30. So you're pitched up at 2 degrees, and your aircraft's flight path is actually -3. The difference between both of them, as we mentioned in that explanation on the slide before, the difference between is 5. So your angle of attack in this situation is 5 degrees. All right. We'll just get rid of all those drawings. And let's talk next about symbology, at least where you can look at the symbology. Then we'll look into the 3 or the 4 different modes of the HUD. We have a primary mode, we have an IMC mode, we have a VMC mode, and an A3 mode. And before you can understand all of that, you should go to the pilot guide put out by Rockwell Collins for the HGS Model 4000, which is the one that we're going to be referring to in this briefing. So in that pilot guide, you have all the information you need, 272 pages of the knowledge you should have before you start your first sim session. Okay? You have acronyms and abbreviations. You should know what they are. The combiner and how to work it. Your instructor will show you that. It's very simple in the simulator. It is the glass piece that you pull down in front of you to look through, onto which the HUD is projected from basically a camera behind you. And there are 3 positions: the stowed position, and then the normal position, and then if you should reject a takeoff, because it is very close to your face, there's a breakaway position, so you wouldn't hurt yourself. You have all the definitions that you need, and you should, to give you an understanding of everything that you're going to be doing in your training session. You have an annunciator panel, which is on the first officer side, and it's called HUD Annunciator Panel, with different warning lights, etc. And you can read up about that, and we'll be covering some of that in future sessions. Anything and everything in the that will be projected on the screen on the combiner, you have references here. So, and you can go to them. We're not going to do it now. We're going to have a look at a few videos. And then a list of all the different tables. Software enabled. There are many options that you can get with HUD, so it depends on what options that your company has bought. All of that, all of those options are listed in the manual. And there's the table of contents. You have different alerts, and these are bookmarks that I have organized in my Rockwell Collins manual. You can do what you want, but I use Adobe Acrobat, and which is a super tool to create and colorize your bookmarks to make it easier for studying. And I've listed all the references and symbols and information alphabetically for studying purposes. Okay, so let's come out of that, and let's go and have a look at video. We're going to look at the primary mode video, and we'll talk about it as we're viewing the video. Here, the on the combiner is a projection of primary mode for runway 12 left at Dubai. Okay, I'm going to run the video, and we'll talk as I'm running it. If you notice, the primary mode, by the way, can be used in every phase of flight, and it is used in all phases. Takeoff, climb, cruise, descent, approach, and landing. And in that mode, you would have both ILSs tuned. And you can learn all about that in the manual. Today we're going to have a look at video. Okay, so we'll get the video going. A3 flashing meaning, hey, I'm available because you have fulfilled all the requirements for A3 if you need it. But we are in a primary mode. Angle of attack I was talking about. There's 5 degrees. And there's your bore sight. There's your horizon bar. And you're pitched up above the horizon approximately 2 degrees, as we were talking about before. There's a 5-degree pitch line reference here. Here's your flight path symbol. I'm going to pause the video just for a second. There's the flight path symbol. And there's the center of the screen over here. And if you notice, the flight path symbol is to the left of the center of the screen. Well, if you look up here, you can see that the surface wind is from the right. It happens to be 210 degrees at 15 knots I've set up. So if the wind was calm, the flight path symbol and the guidance cue and the accelerate, decelerate caret, those 3 items, which are always together, would be at center screen. Conversely, if the wind was from the left, it would be off to the right. As the wind, say, was stronger, let's say this wind, instead of being 15 knots, was your crosswind component limit for landing. Let's say it was 33 knots for all intents and purposes. This flight path symbology would be to the far left of the screen, and it would be ghosted. It would be dashed. The symbols would be there, but instead of solid lines, there would be dashed lines to let you know that you're getting close to the extent of the usable area. So it's very cleverly done, really. Here, 470 is your altitude above ground, your radio altitude. All right, here's your compass rose down here at the bottom. And here is your course line for the runway, which is 119 degrees. And here is your VSI, your rate of descent. And it looks like close to 890 feet per minute. On the left-hand side is your airspeed tape, the way you see it on a PFD. And later on, when we can see the whole picture in another video, you'll see your altitude tape on the right-hand side. Maybe we'll see it in this video as we progress. So what you have to get used to is everything is the same color. And there is your airplane reference, but you are focused here. Your job is to keep the guidance cue, which is the little circle inside the flight path vector or the flight path symbol. That's called the guidance cue. And really, it's a flight director guidance cue. And if you had flight director bars, let me just see if we can draw a little picky here for you. And we'll do that. Let's see if we can get some color here. And let's make them straight lines. So if you had flight directors like so, and like so, you could kind of think of it as that's how you fly and approach with flight directors. Well, your cue is telling you the same thing, and basically it's getting the information from the FCC computers and other computers, HUD computers, etc. So think of the center of the actual cue, this little, in this area here, let's just, the center of the actual cue, think of that as being your command bars. Okay, let's move on. And the caret is your acceleration deceleration symbol, meaning that if you were accelerating, that caret would be above the wing, above the wing. Let's see if we can get some color here. And it would be above the wing here. Ta-da! All right. Meaning that the airplane is increasing in speed. Your speed has no bearing on your particular speed at that time. All it means is that all the forces and all the energy that's happening is that the aircraft's energy is accelerating. Conversely, if you were decelerating, if you brought the thrust levers back and straight in level flight or whatever, and your airspeed was decreasing, the entire energy of the aircraft would be diminishing. Therefore, your symbol would be below the wingtip. So above the wingtip, accelerating, and below the wingtip, decelerating. Too bad it wasn't that way in color of the airplane, but it's all one color. Okay, so the line that you see here is the 3-degree reference dashed line that you've entered into the MCDU before you did the approach that actually mirrors the glide path once you're on the glide path, once you're on the ILS itself. All right, so there's your heading and your track. By the way, very, very, very small. If you are at all unsure about your status as you're learning this beautiful system, put your head down into the flight deck and look at your PFD. Your brain is thinking in color. You've been trained in color. So if you're not sure, look down. And once you get sure, you'll get more confidence in the fact that you're using a flight path symbol and as a flight path vector. That is that flight path that we talked about when I first started this briefing. It's not pitch, it's a flight path. That's the path your airplane is making with respect to the horizon. So that's why the flight path symbol here is below the horizon. If it's below the horizon, it means you're descending. If it's above the horizon, it means you're climbing. Simple. If it's on the horizon, it means you're in level flight. Doesn't matter what your pitch is. If you're at 5 degrees of flap at 60 tons downwind doing a traffic pattern, you'll be pitched up at 6 degrees above the horizon. Your bore sight will be at 6 degrees above the horizon. The aircraft symbol will be 6 degrees above the horizon. Your altimeter will indicate you're bang on the altitude you want to be at. You're not climbing or descending. Therefore, your flight path symbol will be on the horizon. And that's how you fly level flight. And the angle between your pitch angle and your flight path angle is your angle of attack. So in level flight with 5 flap at 60 tons, pitched up at 6 degrees, you're right. Angle of attack, 6 degrees. Let's go back to that video and continue it. Altitude above the ground. There is your speed, your indicated speed, and your actual speed will be over here. We can't see it right now. It's down here. So that symbology we'll look at a little different a little later in a night scene in another mode. So basically, all you do is you're focusing, really, to make it simple, what you're doing is you're focusing your entire cross-check, basically, is here. If that's all you're looking at, that's all you need to look at. That'll take you to where you want to go. as the command bars would do. They'd take you where you want to go. The other very important thing about when a pilot flying, of course, is using the HUD, the pilot monitoring is not using the HUD for obvious reasons. His or her head must be on the flight deck. So your pilot monitoring's duties are highly enhanced because now there are only one set of eyes on the flight deck to monitor engine parameters and everything else. So it's important in your training that your instructor stresses this, that the pilot monitoring is heads down, monitoring everything. He's in and out, in and out, in and out, in this case, because it's a VMC mode. But the pilot flying's focus is on the screen, and he is changing his focus to see the symbology on the combiner, looking through it to the poppy. You can see the poppy there, 2 red and 2 white. So on a visual approach, later on the VMC will talk about it. You don't have guidance on the VMC mode, but you have guidance here, but we'll talk about that a little later. But if you notice, the center of the flight path symbol, the center of the circle, is really through the dashed line, and the dashed line is basically situated on the poppy. That's your glide path. Here we are getting close to, you can still see 2 red and 2 white. And if you can see, the center of the flight path symbol is right on the 2 red and 2 white. At 300 feet, 230 feet. Approaching decision height. And we should be 50 feet over the end of the runway, in which we will be. And now you're actually landing visually. Okay, you're landing the aircraft visually. Okay, so that is a look at the primary mode and the primary a good primary video. We'll stop this briefing now, and we'll see you at the next video where we will look at the IMC mode. Thanks. Enjoy. And if you want a briefing online, especially during this COVID-19 situation we have worldwide, get your partner organized, get yourself on Zoom, get yourself tuned in, and call me or email me, and I'll gladly give you a briefing online. Actually, this is what we're looking at for the future.